Hi everyone, this is your math guru. In this video, I'm going to show you how to solve the following revision questions and number patterns. Please don't forget to click on the like and subscribe button below for more easy to understand math concepts. The first part of the question says, consider the number pattern or number sequence 25, 29, 213, 217. Write down the next two terms of the sequence given that the pattern continues. I'm going to make a list of all the numbers. If you look at the pattern given, you can see that the pattern starts with a 2 and every other number is a 2. So therefore, I know that the next number would definitely be a 2. However, I need to figure out what the pattern is for the rest of the data given. So I'm starting from 5. If I'm going from 5 to 9, there's an increment of 4. So I have plus 4. So I'm going to double check to see if it's a linear pattern or a quadratic pattern. If it's a linear pattern, what it means is I have a common difference. So from 9 to 13, 13 minus 9 will give me a plus 4. From 13 to 17, that's another plus 4. So therefore, the number after the 2 will be a plus 4. So therefore, 17 plus 4 will give me 21. So the next two terms will be 2 and 21. The next question says, calculate the sum of the first 100 terms of the sequence. Note that every other term is a 2. So to calculate the first 100 terms, I'm going to split this up into 2. We have terms in 2s and then the terms increasing by plus 4. So starting with the terms in 2, because I've been given that as 100 terms, I'm going to have terms in 2. So the second part of the question. For terms in 2s, I have 100 terms in total. So the sum of the terms in 2s will be half of the 100 term, which is 50. So that's going to be 2 times 100, and that sum will be 100. So what I've done is, if I have 100 terms, half of that 100 will be terms in 2, and then the other half will be terms increasing by a common difference of 4. So therefore, I need to calculate the sum of the remaining terms. Now, the remaining terms, that's your 5, 9, 13, 17 to the end. The formula for finding the sum of terms for arithmetic pattern or a linear pattern, I have that as my Sn equals n over 2 in bracket 2 times the first term, a, plus n minus 1, then the common difference, d, close bracket. Note that because I know that I have 50 terms left, so that's going to be S50 equals 50 over 2 in bracket 2 times the first term. In this case is not the first term of the pattern, but the first term of the rest of the pattern, starting from 5. So my first term will be 5. So that's going to be 2 times 5, close bracket, plus the total number of terms, 50 minus 1, times my common difference is plus 4. So I'm multiplying that by 4, close bracket. So therefore, my S50 equals 50 divided by 2, that's 25. Multiplying, I have 5 times 2, 10, plus 50 minus 1, 49. 49 times 4 will give me 196, close bracket. That's equal to 25 times 206. Therefore, my S50 for the remaining terms will be 5,150. So therefore, to find the sum of the first term, I am going to have S100 is equal to my S50 plus my S for all the 2's. That's going to be 5,150 plus my S of 2's, which is 100. Therefore, my S 100, that's the sum of the first 100 terms, will be 5,250. Let's look at the remaining part of the question. The B part says the seventh term of a geometric sequence is 3,645 over 64, and the fourth term is 35 over 8. Determine the first term. I'm starting with my Tn for a geometric sequence is AR n minus 1, where A is my first term and R is my common ratio. I've been given the seventh term, so I have my T7 equals A, that's the first term, which is unknown, times R, but my n is 7, so I have 7 minus 1, but the value has been given as 3,645 over 64. So I'm going to equate that to 3,645 divided by 64. So if I tidy that up, I'm going to have AR, 7 minus 1 to the power of 6, equals 3,645 divided by 64. I'm going to tack that my first equation. And then on the other side, I have the fourth term. I'm starting with the formula for my GP, or my geometric sequence. That's AR n minus 1. So to find the fourth term, T4 will be AR 4 minus 1, which is equal to AR 4 minus 1 is 3. And we've been given that value as 135 over 8. So therefore, I'm going to tack that as my second equation. That's equation 2. So therefore, I have two missing variables. That's the first term, A, and then my common ratio, R. So because I have two equations, I'm going to use the simultaneous equation to solve. So therefore, if I say equation 1 divided by my second equation, what I'm going to have is, on my left hand side, I have my AR to the power of 6 divided by equation 2 on my left hand side, that's AR to the power of 3, and that will be equal to, I'm going to do the same for the terms on the right, 3,645 over 64 divided by 135 divided by 8. If I resolve, I have A divided by A, that goes off. Then I have R6 divided by R3 using laws of exponents, so that will be R to the power of 6 minus 3, which is R cubed, equals, then to simplify what I have on the right, that's going to be 3,645 over 64. I keep the left hand side. I change my sign to multiplication, and then I flip it over 135. Simplifying, I have that as 8 here, 1, 1864, 8. Then I have 135 here, 1. I have that as 27. So my answer is going to be 27 divided by 8. And to find the value of R, I'm going to find the cube root of both sides. So therefore, my R will be equal to cube root of, oh, I forgot to put my 3 as shown, because whatever you do on your left, you do on your right. So the cube root of 27, that's going to be 3, and the cube root of 8, that's 2. So the value of R is 3 over 2. So now that I have the value of R, I'm going to pick one of the equations. I pick my T4, such that I have T4, which is equal to AR cubed. So I have A, then R, which is now 3 over 2. So I'm going to replace that. All cubed is equal to 135 divided by 8. Therefore, I have that as 27 over 8A equals 135 divided by 8. Therefore, A is equal to 135 times 8 divided by 27 times 8. And if I resolve that, therefore the value of A will be, I have 18, 8, 1, 27 here 1, 27 here 5. So therefore, A is equal to 5. So therefore, A, because the question says, determine the first term, my A is equal to the first term, T1, which is equal to 5. Let's look at the last part of the question. We have the sum of 5 plus 15 plus 45 to n terms is 605. Determine the value of n. The first step is to determine if this is a linear pattern or a geometric pattern. And to do that, I need to do a quick check. If I'm going from 5 to 15, that's plus 10. 15 to 45, that's plus 30. So therefore, that's not going to be a linear pattern. So going to geometric pattern, I have my R, so I'm solving C, equals the term in front. I'm going to tag my terms quickly, T1, T2, T3 to my Tn. So in order to find my common ratio, is the term in front divided by the term behind, that's 3 over T2, which is equal to 15 over 5. And that is equal to 3. And if you check, 45 divided by 15 will also give me 3. Now we've been told that the sum of this set of term geometric pattern is 605. So my Sn is equal to 605. And we know that my Tn for this geometric pattern, my Tn equals ARn minus 1, which is equal to the first term, which is A, that's 5. And then I have my R is 3, so I have 3 to the power of n minus 1. The formula for finding my Sn for the geometric pattern, S of n, because the value of R is greater than 1, so I'm going to use the formula Sn equals A in bracket R to the power of n minus 1 divided by R minus 1. So therefore, putting in back my values, I have 605, that's the total given, equals the first term, that's 5 in bracket. My R is 3 to the power of n minus 1 divided by 3 minus 1, and that's going to give me 5 in the bracket, 3n minus 1 divided by 2. If I cross multiply, what I'm going to have is 605, this is over 1, so I'm going to have 605 times 2 equals 5 times 3n minus 1, and dividing both sides by 5, I have 5 and 5, 1. So on my left hand side, 605 times 2 divided by 5 will give me 242 equals 3n minus 1. The next step, I'm going to add 1 to both sides, so I have 3n equals 243. That's me moving my negative 1 to the left hand side, it becomes a positive. So therefore, using prime factorization, I'm going to change my 243 to exponential form. So I have 3n equals 3 to the power of 5. And because the base are the same, I'm going to equate the powers. So therefore my n is equal to 5. The last part of the question says that show that the summation of from n equals to 1 to infinity of k minus 3 over 2 all raised to the power of n is equal to 2k minus 3 divided by 5 minus 2k. So I'm going to solve from my left hand side and writing out the terms on my left hand side. If the value of n is 1, because we've been told to start from 1 to infinity, so I'm going to write a few of these numbers. So if n is 1, I'm going to have my t1. If I raise that to 1, I'm going to work it out by the side. So therefore, what I'm going to have is k minus 3 over 2. N is 1, so I change that to 1, which is k minus 3 over 2. So the first term will be k minus 3 over 2. The second term, I'm going to have k minus 3 over 2. N is 2, so I'm going to change that to 2, which remains the same. So the second term is going to be t2, which is in bracket k minus 3 over 2 all 2. So I'm going to do the same for the next term. t3 equals k minus 3 over 2 to the power of 3, and this goes on. Now I can see that that is a geometric pattern, and for geometric patterns the ratio, or they all have a common ratio. So therefore, to find my common ratio, that's r will be equal to the term in front divided by the term behind, which is t1. In this case, I'm going to have k minus 3 over 2 squared divided by k minus 3 over 2. Laws of exponent, this is going to give me k minus 3 over 2. So therefore, the sum to infinity, as shown, we have the formula to be s to infinity from a geometric pattern is a over 1 minus r. My first term, which is a, equals k minus 3 over 2 divided by 1 minus, we've been able to get the value of r, k minus 3 over 2. I'm going to put that in a bracket, k minus 3 over 2. Extend my fraction bar, and if I resolve what I have at the top, I'm going to have 2k minus 3 over 2. Let's put in that under the same denominator. I'm going to do the same at the bottom. For what I have, if I resolve, that's going to be 5 minus 2k divided by 2. So I have a complex fraction there. If I switch that around, that's going to be equal to, that's my s to infinity. Then I have 2k, that's the numerator, 2k minus 3 divided by 2. I'm going to change my fraction to multiplication, and then I flip the denominator, so that's going to be 2 over 5 minus 2k. Here I have my k, 2 in 2 common factors, so therefore that is equal to 2k minus 3 times 1 divided by 5 minus 2k times 1, and you can see that that is equal to my right hand side. So this is equal to my right hand side. So I've been able to show that the sigma notation on the left is equal to my right hand side. Thanks for watching. Bye.